Okay, welcome to an introduction on how we can use our understanding of logarithms and some of their special unique properties that logarithms have to solve exponential equations. So let's take a look at this question. Logarithms. So what? Like why do we have them? What purpose do they serve? So we've spent a couple days where we've learned to manipulate logarithms using different properties. But today we're going to learn why we care as mathematicians about these things. So I have here three different equations, and these represent three different areas of your life where you've been learning mathematics. The first equation, if you're going to solve for x, well, we undo multiplication by division. So we would divide both sides by 5 and we get x equals 6. And over here we have a quadratic, and we undo the squaring by taking the square root. Now, remember, I cannot emphasize this enough, that when you, the problem solver, take the square root, you have to remember that plus minus. And so, of course, the square root and the square undo each other, and we end up getting x equals positive or negative 8. Most kids forget that plus minus. Tragic. Over here, what do? Well, we have the x, but it's trapped up in the exponent. And before you shout out the answer is 4, no, the answer is obviously not 4. But how do you handle this? This is where logarithms come into play, because we've said over and over again that logarithms are exponents. And so how do we solve this? Well, we're going to find out. Before we get too far, though, let's just make sure we understand the power property of logarithms. There were three big properties we talked about: the product property, the quotient property, and then we hit the power property of logarithms. And if you recall, what this property says is if you have a log base b of a number raised to a power, the power property allows you to grab that exponent of y. It lets you grab that y and take it and bring it down here with everybody else. So you end up getting this, y times log base b of x. It allows the exponent to come join everybody else on the same playing field. That is a property that is unique to logarithms. So let's just dive in. Let's see what we've got here. Here's a set of problems. Throughout this video, you should pause the video and jump in. Try these problems on your own. When you're ready, unpause the video and see what I do. Okay, so I'm looking at problem number 1. Let's focus just on problem number 1. I have 5 to the x equals 12. And this is a good time to do a little bit of estimation. You know that x, the exponent here, has to be between what two whole numbers? Well, if you think about it, x is between 1 and 2, because 5 to the first is 5, which is just smaller than 12. 5 squared is 25, which is just bigger than 12. So I know something about x, and it's between 1 and 2. But here's what I'm going to do. Anytime your variable is trapped in an exponent, it is a prime candidate to introduce logarithms. And in this particular case, if we look at our calculator, there are two logarithm buttons in our calculator. There's just log, which you may recall is the common logarithm. It's a log whose base is 10. And then there's this log button, ln. And this is the natural logarithm. The base of this is this irrational number called e. So when I introduce logarithms into this, I want to use only one of those two logarithmic bases. And it doesn't matter if we use the common log or if we use the natural log, they'll both get us the correct answer. So for this first one, I'm going to choose to take the common log of both sides. You remember in math, what you do to one side, you have to do to the other. So I took the common log of both sides. And this is read as the common log of 5 to the x equals the common log of 12. And what this did is you might be thinking, well, this doesn't look any easier or any nicer. But what we've done is we've introduced logarithms. And since we have logarithms, we can use those properties that are unique to logarithms, one of which is the power property. And it says, hey, if you have an exponent inside a logarithm, you can take that exponent and bring it down with everybody else. And if we do that, we end up with this. X times the common log of 5 equals the common log of 12. And now that we brought x down to the same level as everything else, we can solve this for x. Remember, our focus is on x. And to get x by itself, we're going to undo multiplication with division by dividing both sides by the common log of 5. So, having done that, boom, I get x all by itself. Now let's go to our calculator and see how we type this in. So in my calculator, I'm going to type the common log of 12. Now this is really important. I have to remember to close off that parenthesis, so I close the parenthesis, and I divide it by the common log of 5. And that ends up getting me that answer. So it turns out x is about 1.54. And the beautiful thing about a calculator and solving equations is I can check to see if my answer is right. I'm going to go back up to the original equation and type 5, and I'm going to raise it to this number. And one way you can access this number up here is to use this blue answer button. You hit second and then this answer button, and it'll take your previous answer and stick it right there. And when I hit 5 and I raise it to that number, I get 12. And that tells me I did it correctly. Now, those of you with really nice graphing calculators, you may have already explored these green function buttons up at the top. And if I wanted to type this into my calculator and I hit alpha F1, it gives me the opportunity to write really pretty fractions. And so I could write the common log of 12 in the numerator, hit the down arrow key, the common log of 5, and I get my answer of 1.54. Just kind of a nice bonus to having that calculator. Well, why don't you pause the video and try number 3, and then unpause the video and see how you did. Hey, welcome back. When I solved number 3, instead of using the common log, just to shake things up, I used the natural log. I took the natural log of both sides. Again, now that we have a logarithm, I can just take this and bring it down with everybody else. And I get x times the natural log of 3 equals the natural log of 30, dividing both sides. Now this time in my calculator, when I type in natural log of 30 divided by natural log of 3, I'm going to hit the natural log button, natural log of 30, close parenthesis, divided by natural log of 3, close parenthesis, and I got looks like that rounds to 3.10. Well, let's keep trying some more problems, and let's see how you do. Here's another problem right here. And again, you'll notice we have our variable trapped in the exponent. And whenever that happens, again, a prime candidate to introduce logarithms. So I went with a natural log. It was less typing for me. I only had to type 2 letters. I took the natural log of both sides, but you're welcome to take the common log of both sides. Now that I have a logarithm, I can grab the entire exponent and bring the entire exponent down. But when you do that, you have to remember that x plus 5, the entire exponent, is in parentheses. And we're multiplying that by the natural log of 3. Well, there's a lot of ways to solve this, but a very common way would be to distribute the natural log of 3. And this becomes x times the natural log of 3 plus 5 times the natural log of 3 equals the natural log of 20. Now remember our goal. Our goal is to get x by itself. So I subtracted 5 times the natural log of 3 from both sides. And our goal is to get the x by itself. I know the right side looks ugly. Don't worry about the right side. That's your calculator's problem. But the left side, to get that x by itself, I need to divide by the natural log of 3. And sure enough, there's my x. Now let's get this thing in the calculator. I'm going to move this thing over so I can see it. So I'm going to type this into my calculator. So in my calculator here, let's see, I need this whole thing to be the numerator. So the first button I'm going to touch is a parenthesis, because I want to put the whole natural log of 20 minus the 5 times the natural log of 3, the whole thing in the numerator. Natural log of 20 in the logarithm with a parenthesis, minus 5 times natural log of 3 in the logarithm with a parenthesis. I need a second parenthesis to end my numerator, and I'm dividing that by the natural log of 3. And I end up getting that. Now, those of you with the fancier, newer graphing calculators, that fraction feature is really nice. I can type it exactly as it's written. I don't need to worry about those extra parentheses. I can just type it exactly as it's written, and you will see we end up getting the same thing. X is about negative 2.27. Well, why don't you give number 4 a try? Try it however you want. Pause the video and see if you got the right answer. Welcome back. That's the answer I got. Hopefully you got the same thing. Now let's keep looking at different types of exponent. Okay, now notice this problem is slightly different than the others. This has this 3 times 10 to the x. I do have an exponent in the logarithm, so I'm going to have to bring logarithms into this. But what I'm going to have to do is I need to isolate the base. I need this 10 all by itself. I don't want that 3 there. So I'm going to get rid of that 3. How? Divide both sides by 3. Those 3's make a giant 1, and we end up getting, where are we? We end up getting 10 to the x equals 3. And now that I have the base all by itself, I can take a log of both sides. You can use log base 10, the common log, or log base e, the natural log, whatever you want. But once you have a logarithm introduced, that exponent can come down and join everybody else, and we end up dividing both sides by the common log of 10, and we get x is about 0.48. Why don't you try your luck here with number 6? Pause the video, try it yourself. Let's see what you get. Hey, welcome back. I hope ... you ended up getting x is about 0.9. Well, we're running a little bit low, so I'm going to go ahead and give you these last 2. Why don't you try these last 2 problems, pause the video, see if you can solve these and find out what x is. Hey, welcome back. Number 8, when I went to do this, I saw x is up in the exponent. I thought, great candidate for a logarithm. You can definitely do that. You could definitely take a log of both sides, but instead I used a little logic. I noticed that 32 is related to 2. Isn't 32 a power of 2? It's not 2 to the first or 2 to the second or 2 cubed, but 32 is 2 to the 5th. And I realized that if I rewrote 32 as a power of 2, then 2 to the x equals 2 to the 5th. That can only be true if x and 5 are the same thing. So sometimes you can logic your way through problems instead of just robotically using logarithms, like number 9. Number 9, I realized that 1/16 is a power of 4. And so I could use some logic here and say 1/16 is really 4 to the negative 2nd power. Remember, a negative exponent flips a number. And again, if the bases are the same, then the exponents have to be the same. And that's how I got x equals -2. Well, I hope that this helped with your understanding of how to solve exponential equations.